Also in the migration, present 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 in the migration, 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 in the migration. There is something called calibration and something called quality control. What does calibration mean? It means you take a source of radiation, you know its strength and the exact radiation coming from it, and its energy. You know that at a distance of 1 meter, for example, this energy or intensity should be a certain value. Then there is the detector, or the radiation detector, or the monitor, which is the device you use to test and check the device. You say that at this distance the intensity should be, for example, 20, but the detector shows 15. In this case, I have a problem with the accuracy, so I make an adjustment and correct the reading. This is the meaning of calibration, to adjust 15 to 20, so I make the detector measure correctly. This is what calibration means. Any machine or radiation detector you receive from the manufacturer should have a calibration certificate. This is the word calibration. You are calibrating this thing, right? Well, this calibration means that any machine or radiation detector that comes from your manufacturer should have a calibration certificate, indicating that this device is calibrated with known sources of radioactivity or known strength sources. It should have this energy level or provide you with these values. Then you or the medical physicist present start doing something called quality control. This means that every month, or every 2 months, or every 3 months, or every 6 months, or every year, depending on the SOP, standard operating procedure, they are using, they begin to measure with their sources at a certain distance, following a specific procedure, and they start to see if the readings are still accurate after a year. If the readings have changed, then in that case, I will send this detector back to its manufacturer for adjustment and recalibration. That is the meaning of calibration. Now, what is risk assessment? Risk assessment is when you say, well, I currently have a place and this place has radiation. You then assess whether this radiation poses a risk, right? To whom? To the public, the worker, or the patient. The worker's situation is fine, right? So, how do you protect the public from radiation? You need to do shielding calculations, which become part of your risk assessment. First, you need to assess the danger of radiation to the worker. You should establish your dose limits, which are already defined. Then, for the patient, you need to determine how you will protect them using the optimization parameters available. You are addressing all potential risks associated with the use of radioactive sources or radiation and the methods to avoid this risk. How will you avoid radiation hazards that may occur in the event of a fire, for example? How will you respond in an emergency? You should outline all potential hazards and their solutions in case of an emergency, for instance, how you would handle a situation like that. There is something called local rules. These local rules are like standards or guidelines in the control room that specify what to do in case of an emergency. For example, if an emergency occurs, you will first contact the Health, Safety and Environment, HSE, then the Radiation Protection Advisor, and so on. If your dose exceeds the dose limits, you will know how to respond. If you lose your equipment, you will also have a specific way to act. Therefore, having these plans or guidelines in place is essential. Responsibilities related to the quality assurance of radiation protection advice that I was talking about a little while ago involve quality control. You need to perform technical checks every week, every year, and every month according to the regional regulations and the international standards that I am following in order to test the efficiency of the machines and assess the stability of the machines involved. The radiation protection advisor is similar to the safety officer. This is the person who is appointed and who controls and monitors the application of local rules, the implementation of radiation safety principles, and ensures that people are wearing their personal protective equipment and that there are no issues. The dose limits are considered the supervising aspect of the entire process, applying all the rules we discussed earlier. Of course, the radiation workers who are working under my supervision must maintain the integrity of the area. Of course, the people who are working, or the radiation workers that are with me, of course, they must be aware of the machine they are working with. They need to understand deionizing radiation well and be well trained. If there is any incident, they must report it to the employer and inform the radiation protection advisor. They need to be aware of the personal protective equipment available, such as the lead apron, and a report must be made if there are any issues with the lead apron. As mentioned before, all lead aprons must undergo annual quality control checks to test for any cracks. The risk assessment, as I was mentioning earlier, is about explaining what a risk assessment is and what it entails. For any radiation facility, for example, if you want to acquire a CT or an X-ray or establish a nuclear medicine department, before doing anything and even before starting construction, you must submit a file to the national organization. This file should include a radiation protection program, a risk assessment, and your shielding calculations, along with all the necessary documentation. The risk assessment is a very essential part that is required, where you evaluate who will be exposed, assess the level of risk involved, and outline the precautions that will be taken. It's like stating that there is a hazard in a certain place, how you will deal with that hazard, how you will manage it, and what the dose limits are. All of this information is included in the risk assessment and must be submitted to get approval from the national organization before you start your activities or before you operate the facility you have for the equipment. As we discussed in the last topic about dose limits, we talked about the topic of dose limits and dose constraints. If anyone remembers, what is the difference between dose limits and dose constraints? Usually, for just how long? I imagined that I was talking to myself the whole time. I was really absolutely shocked, I swear. Well, the dose limit we mentioned is the one that is set by any international organizations like the IAEA, which is 20 millisieverts for workers, and for the public, it's 1 millisievert, if you all remember. And I mentioned that I have a dose constraint, which I call my investigation level. We were specifically talking about the emboli, or the training for those who are 18 years old and approximately 20 millisieverts. Dr. Islam even asked me about the topic of 150, but I can't remember if he did or not. We said that if it was less than 18 years old, then I have approximately 6 millisieverts. And we also talked about that as well as other related topics. I want to bring you what was available before. It was easier. We talked before and mentioned that I have a dose limit and a dose constraint. The dose limit is, for example, 20 millisieverts per year for workers, and for those aged 16 to 18, it is around 6 millisieverts. We also said there is something called a dose constraint, which is my investigation level. This is the value at which I must stop and conduct an investigation if my worker exceeds this value. For example, it is 6 millisieverts for someone working in radiotherapy or nuclear medicine, and in radiology, it is 3 millisieverts. Of course, these values may vary from one place to another and from one regulation to another. So when we came here, for example, we looked at here, the topic is carefully divided based on what we discussed about having a controlled area and a supervised and monitored area. The supervised and monitored area is where a worker can be with a patient, such as in injection and treatment rooms. If the dose for a person in this area is likely to exceed 6 millisieverts, I carefully consider this area as a controlled area. I'm specifically mentioning this because I'm referring back to the 2017 regulations we are working under, and I want you to be well informed about this because you need to understand and comprehend why this area is referred to as a controlled area. The detailed classification we discussed is because the worker in this area is likely to have a dose exceeding 6 millisieverts. Now, why is that? Because they are a qualified radiation worker. The supervised and monitored area is significantly less hazardous than the controlled area. It can have both patients and workers. Here, the likelihood of the dose exceeding 1 millisievert is lower, so you can safely reduce your exposure limit a bit. Larger than the controlled area, which is related to the 6 millisievert for the public, I name this the supervised area. This relates to the naming of controlled area and supervised area. Now, regarding dose constraints, just so you are aware, dose. Constraints are considered the investigation limit. The investigation limit means that if I exceed this dose, I need to understand why. I shouldn't wait for my worker to reach 20 millisievert before taking action. The system I work with operates on the 6 millisievert limit, not the 20. So, in my calculations, when someone tells me they have a device that allows the worker to reach 6 millisievert per year, it should not be 20 millisievert per year. Is everything okay? Good. When I come to work, I do the shielding that reaches the color millisievert. It's not about the sexy millimeter. I am working on that limit. This limit might vary from country to country, or it could change from the value that I was supposed to show you is the one that is here. The one that is here. It is connected or present in the International Atomic Energy Agency. The same dose, criteria apply. In the event that there is a problem with the equipment, such as, for example, a report should be made to the Health Safety Executive or the Health Safety Environmental Organization. If the dose is supposed to be a certain value, for instance, 1.5 multiplied by a factor of 1.5 in the case of a fluoroscopic procedure, CT scan, or interventional procedure, and if the dose exceeds 1.5, you must report to health safety that a problem has occurred. There are also other necessary procedures that need to be followed according to the national organization in order to ensure that the appropriate steps are taken. Here, we must report in case there is an exceeding of the dose limit or the normal dose that should be taken due to a failure in the machine or an issue that has occurred with the machine. Of course, the patient must be informed about this problem and the dose they received effectively. Here, of course, since I am talking about CT, fluoroscopy, and interventional procedures, it is considered 1.5 doses, meaning 1.5 times. However, since the dose is already high from fluoroscopy, CT, and interventional procedures, when you go to mammography or regular X-ray radiography, the dose is actually low. In mammography, you are dealing with a breast, which is a sensitive organ, and the dose is 10 times that of X-ray. For X-ray, dental X-ray, and extremities, it is 20 times the dose. You should make your report and notify accordingly, meaning 20 and 10, 1.5, depending on the original dose level, whether it was a lower level of dose, or a low dose, or high dose. Here, the 1979 regulations on the administration of radioactive substances address the topic of administering radioactive material, the field of radioactive material, and the appropriate doses for examinations. This includes how much dose one should receive for a specific examination. All of this is clear, right? It does not apply to substances that are naturally radioactive or administered for purposes other than radioactivity. Here he wants to say that it is not related to what they call, for example, sometimes certain radioisotopes used in non-clinical procedures. He wants to say that it is not related to this topic. The text refers to what is sometimes called the in certain radios, specifically types that are used in the field. I only work specifically on the topic of clinical procedures or administration lobby for clinical purpose, okay? But otherwise, if you are using radioactivity for any other procedures or anything else, that's it. This is not included in the regulations of the Radioactive Services Administration. Well, these are obviously the people who are working or who are employed in various sectors and industries across different regions and fields of expertise, contributing to the economy and society in meaningful ways. A nuclear medicine physician who is a specialized medical doctor must have a valid and recognized certificate or credential that clearly states and verifies that this person is fully capable and competent in performing the specific medical examinations and procedures they are qualified and authorized to conduct. In the field of work that involves handling or being in proximity to radioactive substances, there is a crucial aspect that must be addressed, which is the certification process. This certification is not just a mere formality, but a comprehensive program designed to ensure that individuals who are engaged in such activities are fully equipped with the necessary knowledge and skills. The certification process is akin to the standards applied in various professional fields where safety and precision are paramount. For instance, in the medical field, professionals who operate radiological equipment must undergo rigorous training and certification to ensure they can safely manage the equipment and protect patients from unnecessary exposure. Similarly, in industries dealing with radioactive materials, workers must be certified to handle these substances safely. This certification involves understanding the regulations and guidelines that govern the use of radioactive materials. It is imperative for those responsible for conducting tests or working directly with these substances to be aware of the potential risks and the safety protocols that must be followed. The certification process typically includes a series of educational modules, practical assessments, and examinations that cover various aspects of radiation safety, emergency procedures, and regulatory compliance. By ensuring that all personnel are certified, organizations can maintain high safety standards and prevent accidents that could have severe consequences. Therefore, the importance of certification cannot be overstated, as it plays a vital role in safeguarding both the individuals involved and the environment from the potential hazards associated with radioactive substances. Here, the Radioactive Substances Act 1993 discusses in detail the topic of storage. As I mentioned earlier, if you have radioactive material that you used in a generator, that generator must be kept in a secure and safe storage location. The storage of this radioactive substance must comply with all necessary regulations, such as placing it in a shielded area. What are the specific requirements for effective shielding? The location must not cause radioactive contamination, ensuring that a person standing outside this storage area is at a high level of safety and protection. All of this relates to storage, handling, and disposal procedures as well. For instance, after use, if you want to dispose of it, how do you properly connect this generator to the supplier? And how does the supplier take back the radioactive material? All these procedures are measured. Even when I receive my shipment, I need to exercise careful handling and caution. Now, when I receive a set of tests conducted on it, I test to ensure that there is no radioactive contamination on its surface. I tested that at a distance of 1 meter, for example. The radiation coming from it compared to the existing projects is the same number. I test the existing projects, the same data and all these things. It must have been it, definitely, indeed, certainly, without a doubt. The procedures involve thoroughly checking and verifying the specific values and parameters, or ensuring that the individual can effectively manage and handle my container or radioactive material that is being received and processed in the facility, and starting the contamination control and prevention process to prevent any potential hazards. I will carefully check and assess with the detailed survey and inspection, is there any external radiation levels? Is it adequately shielded and contained properly to prevent exposure or not? All of this is extremely crucial and important for the safety and security of the operation in successfully obtaining and securing the shipment, and everything is thoroughly documented and recorded repeatedly for future reference and accountability until it is recorded with me, carefully noting and documenting why this material entered and what was accurately recorded on a specific date and time, with all relevant details with the specified activity and purpose, so it can be referred to and reviewed in the comprehensive report that clearly indicates and outlines whether this material is acceptable or not for processing and use for me. Okay, the transportation process. As I mentioned, for example, you will find that when we transport a material,